Today's class we will discuss vapor pressure. What is the vapor pressure? We consider a body of liquid and there always exist some gaseous phases on the top of the liquid and it creates a pressure on a liquid. This is called vapor pressure. For example, you leave a body of water. Some molecules from the surface of the liquid will leave into vapor phase and that will create a pressure on the liquid itself. This is called vapor pressure. This vapor pressure is related to the temperature. If the temperature increases, the vapor phase also increases. That means the layer of the water molecule will become more and the pressure will be more. So we now understand, once the temperature of the body increases, the vapor pressure of the body also increases. Now at a particular temperature, the vapor pressure of the body will be equal to 1 atmospheric pressure and that particular temperature is known as boiling point of the liquid. So in short, the boiling point of a liquid is a particular temperature when the vapor phase of the liquid will become 1 atm pressure or 1 atmospheric pressure. This is called boiling point. For example, boiling point of water is 100 degree centigrade. Now we consider these two beakers, A and B. A is mixed with solvent, B is mixed with solution. That means this beaker contains pure solvent, say for instance water, and this beaker contains solvent and solute. Say solvent is water, so and solute is sodium chloride or sugar, whatever may be soluble. Now these are the layer of liquid reaching the top phase. Top phase in the sense, here from the liquid molecules will leave into the gaseous molecule and there existence of some molecules that creates a pressure is called vapor pressure. But here see, the number of molecules leaving the body will be reduced because there is some solute molecules are here. So automatically you understand this will decrease the vapor pressure. So we can understand at a particular temperature the vapor pressure of solvent should be little high than the vapor pressure of the solution. So it is clear what is called vapor pressure. See, molecules from the liquid body will leave it and will form a layer on the top of the liquid body in gaseous phase and ultimately it will exert a pressure on the liquid itself is called vapor pressure. Now this is temperature dependent. That means, say for instance, if temperature considered as 50 degrees centigrade, the vapor phase may be 1 centimeter. But if it is increased to 75 degrees centigrade, it will increase more than 1 centimeter. In this way, at a particular temperature will reach when the total body or the liquid body will move into the vapor phase and the vapor pressure will be equal to 1 atm pressure and that particular temperature is known as boiling point. So you can consider what is boiling point. Boiling point is the particular temperature at which the vapor pressure of the liquid become 1 atm pressure. So in short, we understand that if there is presence of certain solutes molecule in the pure solvent, the vapor pressure will be decreased. Now, what does it mean? It means presence of solute will change the normal behavior of the solvent. Solvent and solute. If the solvent will show a particular type of character or properties where presence of certain solutes in the form of soluble solutes will change the property. So we can call it vapor pressure is a colligative property of the solvent. Consider this figure. P0 is a pure solvent vapor pressure. Small p is a solution vapor pressure. Delta P is a change in vapor pressure. That means pure solvent vapor pressure minus solution pressure. Okay? Follow the board. Chi1 plus Chi2 is equal to 1. That means mole fraction of the solvent plus mole fraction of the solute, total value should be always 1. Now, as for the equation, last time we discussed, partial pressure of the solution, that means solvent plus solute, should be equal to chi solvent or mole fraction of solvent, that is Chi1, into pure pressure of the solvent molecule. And what is delta P? Obviously, solvent pressure, pure solvent pressure minus solution pressure. That is equal to P0, and if we replace partial vapor pressure of solution, we can get it P0 into Chi1. Consider this thing, taking P0 constant common, 1 minus Chi1 is equal to P0 into Chi2. Now delta P by P0 is called relative lowering of vapor pressure. Delta P by P0, that means P0, pure pressure of the solvent is considered as relative lowering of the vapor pressure. So ultimately we got it, delta P by P0 should be equal to Chi2. So from here we can understand, more number of solute you add to the solvent, more depression of the vapor pressure will be there. Follow this equation. Delta P directly proportional to the Chi1. Chi1 is the mole fraction for the solvent. So what is Chi1? Solvent molecules to the proportion solvent plus solute molecule. If solvent molecule is N1 and N2 is the solid molecules, then Chi1 is equal to N1 by N1 plus N2. So now we can understand that lowering of vapor pressure is directly proportional to the mole fraction of the solvent. According to Henry, the pressure of a gas on its solution and the solubility fraction is directly proportional. So according to that law, if the pressure of the gas P on the solution and fraction of molecule soluble in the solution liquid or solution is directly proportional, and proportionality constant is KH, which is known as Henry's proportionality constant. So from this you can understand, once you increase the pressure, more soluble will be the gas. Once you decrease the pressure, the solubility will be reduced. Example, when you put carbon dioxide in a bottle, you have to increase the pressure. More carbon dioxide will be soluble. Once you open the lid, pressure reduced and excess carbon dioxide is squeezed out. This is the main principle of Henry's law.